Have you ever wondered what really makes your computer feel so snapping and responsive? That instant on feeling? Well, it's not just about the big name parts like the processor or the RAM. Today, we're going to pull back the curtain on the unsung hero of high performance, cache memory. Let's dive in and uncover your computer's real secret weapon for speed.
So, what is this secret weapon we're talking about? Well, it's this component that works tirelessly, completely behind the scenes, pretty much anticipating what your computer's going to need before your computer even knows it needs it. You can think of it as the critical bridge between that lightning-fast brain and the much slower places where data is stored.
And that, right there, is the job of cache memory. Okay, so picture your computer's brain, the CPU, as this brilliant but super impatient genius. It can process information at just incredible speeds, but it's often stuck drumming its fingers, waiting for data to arrive from your main memory, the RAM. Cache is the solution. It's a small, exclusive, high-speed little storage spot that keeps the most important, most frequently used data right next to the CPU. And when the CPU finds what it's looking for there, that's called a cache hit. And that, my friends, is a huge win for performance.
To really get a handle on this, let's use an analogy that'll make it super clear. Imagine your CPU is you, and you're hard at work at your desk. Now, the main memory, or RAM, that's like a huge library way down the hall. Getting information from there, it takes time. It takes effort. Cache memory, that's your personal, highly organized workspace right there in front of you.
But here's the thing. This smart workspace isn't just one big pile of papers. No way. To be truly efficient, it's actually split into two main levels, and each one has a very specific and very important job to do.
So let's start with the most exclusive level, the absolute VIP section of your computer's memory. This is level 1 cache, the inner sanctum of speed.
The most important thing you need to know about L1 cache is its location. It's often called internal cache for a reason. It's physically built right into the CPU chip itself. I mean, you can't get any closer than that. This extreme proximity means there's practically zero travel time for data, which makes it the smallest, but without a doubt, the fastest memory in your entire system.
And this brings us back to our workspace. The L1 cache is literally that one crucial post-it note you have stuck right on your screen. It can't hold much information, maybe just a key phone number or a critical password, but it's the data you need instantly, without even having to turn your head. It's right there.
Okay, but a single post-it note can't hold everything you need to get your work done, right? Of course not. So, for all the information you access really frequently, but maybe not this exact second, we have the next layer, level 2 cache.
Level 2, or secondary cache, is like the trusty assistant to level 1. It's located just outside the CPU, usually right next to it on the motherboard. Now, the trade-off for this little bit of extra distance is that it can be much, much larger than L1, even though it's just a tad slower to access.
So, back in our workspace, this is that small, perfectly organized filing cabinet right by your chair. It holds all your current project files. Sure, it takes a moment longer to open a drawer and grab a folder than it does to just glance at your post-it note, but it's still incredibly fast and convenient compared to that long, long walk down the hall to the main library.
So you might be thinking, okay, which one is better, L1 or L2? But that's really the wrong way to look at it. They aren't competitors at all. They're partners in this beautifully tuned system. In fact, most modern computers actually add a third level, an L3 cache, that's even larger and a bit slower, acting as one final backstop before the system has to go all the way to the main memory.
So, let's see how this partnership really works. The CPU first checks its post-it note, the L1 cache. If the data's there, boom, super fast cache hit. If it's not, that's called a cache miss. It then immediately checks its filing cabinet, the L2 cache. If it misses again, it might check L3, and only then, as a last resort, does it make that long trip to the library, which is the main memory. This whole hierarchy, this system, saves an incredible amount of time.
This all seems pretty clever, but it does raise a question, right? Why not just make all the memory super fast, like L1 cache? Why even bother with all these different levels? Well, it all comes down to a fundamental trade-off in engineering.
Here's the bottom line. The tech that makes memory incredibly fast also makes it incredibly expensive and really limits its physical size. You just can't build a massive, affordable L1 cache. So this whole tiered system is this really elegant compromise. It's an economic and engineering solution that gives the processor instant access to what it's most likely to need, while keeping all that larger, less urgent data just a heartbeat away.
You know, this quote just sums it all up perfectly.
cache isn't just one thing. It's the intelligent bridge that connects the two extremes of your computer's memory. It's this hierarchy of foresight that allows that impatient genius, the CPU, to just work and work without constant interruption, making the whole system feel seamless and fast.
And that really brings us to the end. This elegant, multi-level system has been the bedrock of computing speed for decades. And it really makes you wonder, as we keep pushing the boundaries of processing power, what will the next smart workspace look like? What's going to be the next secret weapon for speed? Thanks for joining me.